So this question involves solving trigonometric equations. Let's read and see what's going on. Solve for the range x between 0 and pi by 2, the equation 4 sine x equals sec x. First thing to do is notice that sec x is just 1 over cos x. So let's use that and see where we end up. So we're left with 4 sine x equals 1 over cos x. So let's times both sides by cos x to simplify the equation. By the way, I've just replaced sec x with 1 over cos x here. So now we're left with 4 sine x times cos x equals 1. And now, we might be a bit stuck here, but what we need to realize is that we can use our double angle formula here, because we have a sine times a cos. Remember, the double angle formula for sine is 2 sine x cos x equals sine 2x. You can get this from your formula book. So to make this left-hand side match that, let's divide this by 2. So now we're left with 2 sine x cos x equals a half. And now place it with sine 2x, we're left with sine 2x equals a half. Now before we start solving this question, bear in mind that we now have 2x instead of just x, which means our original range has gone from 0 to pi by 2 to 2x is between 0 and pi. Now we know that, we can continue solving our question. So 2x is therefore going to be inverse sine of a half. Now, we can use a cast diagram to help us here. C-A-S-T, written like that. What the cast diagram tells us is when trigonometric curves, so sine, cos, and tan, when they're positive and when they're negative. So C here, in this quadrant here, is when cos is positive, but sine and tan are negative. A here stands for all, when all of them are positive. S here stands for sine, when just sine is positive, but not tan or cos. And T here is when tan is positive, but not cos or sine. Now we're dealing in the two areas, or the two quadrants rather, where sine is positive, because we have a half, not negative half, which means we have this quadrant here and this quadrant here. So we can draw our lines like that, and we can fill in our angle like that. So first let's do inverse sine of a half, and make sure we're in radians for this. And we're left with pi over 6. Which is that this angle here is pi over 6 and this angle here is pi over 6. Which means our two solutions is that 2x equals pi over 6, which is this one here, but also pi minus pi over 6, as we're going a whole time round and back pi over 6. So that's going to leave us with 5 pi over 6. And now we want to find out what x is, not 2x, so dividing both sides by half, we have x equals, one more thing is, we've only gone round once pi amount of times, because we're in the range 0 to pi, and not anymore. So we only have two solutions now. Now dividing both sides by 2, we have x is pi over 12 and 5 pi over 12. And that fits in the range of our original range between 0 and pi over 2. So that's it for this question. In terms of the marking for this question, you'll get 2 marks for finding 2 solutions, a mark for using the double angle formula, and a mark for realizing that sec x is 1 over cos x. And that's it, 4 marks for this question. So let's move to part 2 of this question. Solve for the range of theta between 0 and 360 degrees, the equation 5 sine theta minus 5 cos theta equals 2. We need to give answers to one decimal place. First thing to notice is that we're in the range of 0 to 360, so let's change our calculator to degrees so we're not in radians anymore. Now, to solve this equation here, we're going to have to express, we can't solve it normally, so what we need to do is express 5 sine theta minus 5 cos theta into one trigonometric form. And to help us here, we can use the compound angle formula. So compound angle formula, say we have sine theta minus alpha. Well, that's the same thing as sine theta cos alpha minus sine alpha cos theta. And now let's times everything by, let's say, r. Then we're left with r sine theta minus alpha equals r sine theta cos alpha minus r sine alpha cos theta. Now we want to express this into one trigonometric form, which is this. So what we're going to do is we're going to equate this right hand part of the equation here to this, and then we can solve for r and alpha, and then plug r and alpha into here, so we have this expressed as one trigonometric form. So let's do that. So now we have r sine theta cos alpha minus r sine alpha cos theta, which equals 5 sine theta minus 5 cos theta. And now what we're going to do is we're going to compare coefficients. So the first thing to do here is let's compare coefficients of sine theta on both sides. So comparing coefficients of sine theta, we have on this side, our coefficient of sine theta is going to be r cos alpha. So we're going to have r cos alpha on this side. And our coefficient of sine theta on this side is just going to be 5. So we have that. And I'm going to call this equation number 1. Now let's compare coefficients of cos theta. Well, coefficient of cos theta on this side is going to be minus r sine alpha. So on this side we have minus r sine alpha. And on the opposite sides we have minus 5, the coefficient of cos theta. And I'm going to actually simplify this expression by just cancelling out the negatives on both sides. So we just have r sine alpha equals 5. And I'll call this equation 2. Now in order to solve for what alpha and r are, we can use some trig identities. So first thing we can do is let's take 2, it's equation number 2, and divide it by equation number 1 and see what we're left with. So doing this, equation number 2, r sine alpha, divided by equation number 1, which is r cos alpha, is going to give us 5 over 5. And simplifying this, well, the r's cancel out here, and sine alpha over cos alpha is just tan alpha. And 5 over 5, well, that's just 1. And now we simply just take the inverse of 1 and find out what alpha is. So alpha is going to be inverse tan of 1, which using a calculator will give you 45 degrees. And now let's find out what r is. So now what I'm going to do is I'm going to do the equation 2 squared plus equation 1 squared and see what we're left with now. Now equation 2 squared will give us r squared sine squared alpha plus r squared cos squared alpha, which equals 5 squared plus 5 squared. And now what I can do is I can factorize out the r squared here. So I'm left with sine squared alpha plus cos squared alpha, which equals 5 squared plus 5 squared, which is 25 plus 25, which is just 50. And now what I can do is I can use a trigonometric identity that sine squared alpha plus cos squared alpha equals 1. And so I can cross this out and this just equals 1. So now what I'm left with is r squared equals 50. And so r is the square root of 50, which simplified into 1/3 will give me 5 root 2. So now what I can say is that the expression we had before can be simplified as just 5 root 2 sine theta minus 45, 5 root 2 is r, and alpha was a 45, equals 2. Now this becomes a much easier question to solve. So first I'll divide by 5 root 2, so I'm left with sine theta minus 45. Now 2 divided by 5 root 2 and simplified will give you root 2 over 5. Now I can take inverse sine of both sides, so I have theta minus 45 equals inverse sine of root 2 over 5, which gives me 16.4299 ... However, this isn't all, as we have one more solution to look for as well. Remember that our given range was from 0 to 360. So we need to find all the sine values in that range. So using our cast diagram here, which I can draw neatly in here, where this is C, A, S, T cast, where this region for C represents when cos is positive, this region represented by A is when all trig equations are positive, this region represented by S is when sine is positive, and this region here with T is when tan is positive. And so sine is a positive function here, which means we're looking at these two quadrants. So we have one solution for sine, which is this angle here, 16.429 and so on. But we also have this other solution for sine here, where that angle is 16.429, However, the full way round is going to be 180 minus that solution. So 180 minus 16.4299, etc. will give me 163.57, etc. And we don't have any more solutions, because if you go around this 360 degrees, well, we only get 2 solutions. And now this is the answers for theta minus 45. But we're looking for the answers of just theta. So let's add 45 to both of these solutions. So 16.4299, etc. plus 45, which gives us 61.4. And 163.57 plus 45 gives us 208.6. And both of these, if you've noticed, are to 1 decimal place, as that is what the question asked for. We need it to 1 decimal place. And that's it for this question. In terms of the marking, you'll get 1 mark for getting both of these right answers. You'll get 1 mark for getting to this stage before you add on the 45, so that's 2 marks. You'll get 1 mark for finding what R is. You'll get 1 mark for finding out what alpha is. And you'll get 1 mark for even trying to apply the R sine theta minus alpha equation, for a total of 5 marks for this question.